Hello, Stella.
Hi.
How are you today?
I'm doing pretty well. I don't know if you can hear, but it's howling. The wind is howling.
It,
We've been in the middle of
it's
a windstorm
fine.
for like 36 hours. So
It's
I'm
okay.
just trying to keep all the windows closed and ignore the screaming noises outside, but I'm doing well.
Awesome. Can you talk about yourself little bit for those who don't know about you?
Sure. So my name is Stella. I'm a mathematician who got into machine learning research about 2 years ago, 3 years ago. I'm part of a online research group called Eleuther AI, which started off as a meme in a Discord channel, and now we've like published papers and stuff. So that's pretty cool.
Awesome.
um, yeah, I am very interested in language modeling research, both in terms of its applications to developing new technologies, and also in terms of using kind of the social impacts of language models. This is something, since GPT-2 came out, people have been talking about this potential social impacts of language models, um, propagating bias, producing fake content, all sorts of stuff, and those are very interesting to me as well, as kind of like social issues surrounding them. Also, anything with a lot of math is good.
What does your day-to-day job consist of? Do you work in predictive analytics or NLP mainly, or
So
computer vision?
I yeah, I am a words. I am a machine learning researcher in industry. So my day-to-day life, when I'm not being hosted on wonderful podcasts, mostly involves reading papers, writing code, testing implementations. I work for a consulting firm, and basically, there's a lot of people who would benefit from more customized machine learning technologies than the sort of standard off the shelf stuff, but aren't large enough companies to do their own research. Amazon, Google, Spotify, they have research departments that can do their research for them. Your typical 400-person company maybe can't afford to have researchers on staff. So we work with organizations that don't have the ability to kind of like have their own research staff, to do research and develop new algorithms for them.
And how did you get into machine learning? How long has it been since you started doing it?
So I somehow like dodged obtaining any knowledge of machine learning in school, which is particularly amusing because one of my research idols now is actually a professor at like a university I graduated from, and some of his coolest work was done while I was a student there, and I just didn't know about it. His name's Reese Condor. He does a lot of stuff with like equivariant convolutional neural networks. Um, and I think that work is super cool, and I just like did not know that it existed, that he existed when I was at Chicago. So I got an industry data science job basically because I had burned out in college. In undergrad I burned out and was planning on doing a math PhD, and one of my professors said, "You can't go. I will not write you a letter of recommendation for a math PhD because if you start a math PhD now, you will not finish it." I was like, I see.
so,
So
so
I decided to take a break and go get like an industry data science job. And then I transitioned from a traditional data science role to a more research oriented role. And now I've been doing research in industry for 4 years, and it's just kind of taken off on its own, I guess. I've thought about going back and doing a PhD, but at the end of the day, like PhDs exist to be entry level research jobs, and I have an entry level research job. So I think I might just kind of stick with what I'm currently doing and try to avoid the
um,
route.
did you have any graduate graduate school? Did you ever have you ever been to a graduate school? Is it like you only have like a bachelor's degree and you are publishing amazing papers?
Well, so I finished my undergraduate degree in 2 years, and
Yeah.
spent the second half of my undergrad, like I finished the requirements for a mathematics degree in 2 years, and spent the rest of my time in college taking philosophy classes and graduate mathematics courses. So I had taken like 9 graduate courses, and written a paper by the time I graduated college. I'm also right now a master's student. In my free time, from my free time, um, I'm a master's student in computer science at Georgia Tech, which is a lot of fun. Wrapping that up soon. I started that a long time ago when I had a lot more time on my plate. And now that I've gotten more involved with research and um, doing research in my free time too, in addition to doing it at work, I have a lot less time than I used to. So I'm kind of looking forward to finishing up the schooling. But I've learned a lot. It's a really good program, and I'm very, very happy to be doing it.
How hard is it to have both the open source work like GPT-Neo and the pile and the masters and the school? It's quite a struggle. The masters and your job, full-time job. It's a
Yeah,
struggle.
I mean, I definitely keep busy. To an extent, I can. I have more time than 24 hours in a day or it feels that way because a lot of my job involves writing code and then running it for several hours, and a lot of my research involves
Okay.
writing code and then running it for several hours. So you can kind of get like 8 hours of work done in 4 hours if you spend half of it writing code and half of it running. Like if you run code for one thing while you write code for the other.
Things to do meanwhile your model is training, I guess.
Yeah. It's which has become a lot easier with the pandemic and being at home, and can't exactly bring my personal computing devices to the office and stuff. But so that's actually made that a little easier. But it's I mean it's a lot of work. I am someone who kind of has always done best under pressure, and like I
Neat.
find time to do the things that are on my plate more or less, no matter how much time I have. Like I always find myself with the same amount of free time, the same amount of downtime, so I might as well kind of load it up. I'm not going to say I'm not going to be excited to get some time back though when I finish my master's program, which will hopefully be next spring will be my last class.
Awesome. You told me that you as a member of the Alert AI. I can't spell it right, I guess. How do you spell it? Eleuter, right?
ELEUTHER.
You have started building the pile for the GPT-Neo in mind. So it wasn't like, hey, we built a data set, so now what to do with it? How was the process like? You started building the pile and then you trained GPT-Neo. That's actually one of the best community efforts ever, in my opinion. Something, like you are doing something that only big tech companies actually do as a community, and it's pretty big. Even though at first I was like, why do we need a second GPT-3? GPT-3 is already incredibly sexist and racist. And then I have read your paper, and for instance, like you have avoided using Reddit, for instance, because I mean it's quite sexist and it has a lot of bias. I want to know which kind of reprocessing different you have done from just replicating the process of training a GPT-2 and GPT-2 or GPT-3. What was the process? What have you learned? What was an interesting that you have came across? So can you talk about it a bit?
Sure. So Luther AI got started with this project GTP-Neo that you've mentioned a couple times, where we said, hey, it would be really cool to do an open source replication of GTP3 and just like publish it online for anyone to use. There's a little asterisk after the for anyone to use because like it doesn't fit on a typical consumer GPU, and so you'd have to like buy like cloud computing time to run it.
Computing resource.
Yeah. So definite asterisk after for anyone to use, but at least for anyone to access without having to go through OpenAI. And I mean, on the one hand, you're right. Like, there is not, I think, a huge amount of value necessarily in creating more things like in creating like replications of large models like GTP3. However, in this specific case, the fact that OpenAI is very closed off about how you can use it, about who they give access to. You have to sign up and wait in a queue to get approved, and then they throttle the amount of access you get to it. So in this specific instance, I think that having an open source replication is very valuable because the technology is already out there. The technology is already being sold for profit by OpenAI and Microsoft. As a general rule, my personal policy is that anything that's safe enough to sell to Microsoft, safe enough to let everyday people use. That's, I think, a pretty decent rule of thumb. So because these models already exist and because these models are already out there, we don't see there being a huge amount of downside to open sourcing them. Yeah.
Agreed. I think it's a great step for the democratization because there is not so many people who can also pay for the GPT-3 inference, as well as getting access. They are picky, I guess. I saw some people who couldn't get any access, and not so many small-sized or average-sized companies may be able to pay for the inference. So it's a great effort for democratizing AI. I really appreciate that. The reason why they didn't do it, like their justification was that it can be used to generate fake news. It can be used to, like it has abusive language, etc. And I mean, yeah, it is. I mean, it has bias inside, but maybe they could have solved it and just released it afterwards. They just released it, and I mean, there isn't even open source inference API. I saw you released in Hugging Face. I guess there was an inference API of the GPT-Neo, which I didn't try yet, but I saw people trying it, and it looks really cool. How was the creation of the pile? Because it's gigantic. It's 800 gigabytes, and it's included Gutenberg, YouTube subtitles, PubMed, like Enron emails, right? Many sources of text. How did you decide upon which source of text you were going to use and not use? Like, how was the creation process?
So one problem that we being the Luther group have kind of had with existing large language models is that the data they're trained on is really bad. And I don't even mean like full of racial slurs or whatever. I just mean it's exceptionally low quality. It's poorly written. I mean, the vast majority is scraped from the internet. And that means it's not very well written. It doesn't contain a lot of factual information that you'd be interested in. Like websites like Wikipedia are very high density in facts, but the vast majority of websites are not Wikipedia. The vast majority of websites are very loaded density in terms of like actual facts about the world. And you could see this with GTP2 to an extent where it would give you answers to questions that kind of didn't make sense, and then you'd go and Google it and you'd be like, oh, like this is wrong, but these words show up together on websites. And so we wanted to kind of push towards something that was actually going to have a higher density of information about the world. We think that, I mean, there's basically unlimited ability to scrape data from the internet because there's just so much text online. But I think that there's a lot of performance gains to be had by using better data. And like really the bar is really low. I want to emphasize if the typical document was like a short essay written by a 16-year-old who's a native English speaker, that would probably be in the top quarter of all English language text that GPT-3 was trained on. Like, it's just not very good text. And if you look at a lot of the other kinds of models that get trained on stuff like this, a lot of the text that they get trained on is auto-generated. A lot of the text is stuff that people don't really pay attention to where it's coming from because it came from Common Crawl, which means it could be from anywhere, or very, very large data dumps that are not necessarily sorted by sourcing. And so we really wanted to know what we were putting into our data set, and we really wanted to know kind of what sorts of information it would contain. And so when we went to choose places to scrape and stuff in data to put in the pile, we were specifically choosing things that we thought would add interesting diversity of textual structure and also interesting diversity of information. So, for example, we went and sought out things like PubMed Central. We were like, we have a lot of math and physics and computer science. We don't have a lot of like biological science type stuff. So we went and we looked at kind of what data sets were out there, and we were like, okay, bioRxiv seems like a good place to get just quality information about biology. We went and we scraped the Stack Exchange website, partially because of the structure. A lot of people want to use language models to do question and answer type things. And so training it on documents in part that are already structured as questions and answers was something that we hoped would improve its ability to do that. And then just the information that contains is very interesting. Most of the content on Stack Exchange is from Stack Overflow. But the other major communities also have some really interesting data that's not necessarily about about computer science. There's a large mathematics community on Stack Exchange. There's a large hardware community, actually. Like power users, like networking stuff and hardware stuff is also a decently large community. And that's just like information that we didn't think we would necessarily otherwise have access to. And on the mathematics side, we saw it as a good bridge between, on the one hand, we have like arXiv, which is research papers, and then we have like basic arithmetic problems from that DeepMind put together. But kind of the typical problem on math Stack Exchange is like high school or first year college level math problems from homework that people don't understand. And so kind of getting that information seems like a good bridge between the really basic, like, this is how you do arithmetic, and the more high level, this is my research paper. So that's largely a lot of what we were looking for. Factual diversity. You mentioned Enron. So Enron contains business information that we don't really particularly think would exist anywhere else. And it also contains, it's also emails. Like, emails are written differently from other text. And so people might want to use this to make emails, and accordingly, it would be good to have it know what emails look like. We wanted to get more diversity in the textual structure, but that didn't end up working out very well. Twitter is just extremely low quality data, was a big blocking point. We looked at like short fiction, but really the only place we could find like short fiction was from fan fiction websites, where the quality was extremely inconsistent, to say the least. A shocking amount of fan fiction is just like, and again, when I say high quality, I'm not even talking about like, oh, I don't think this is a good story. I mean, like, I don't think that this is proper, like, was written the way the author intended it to be written. So yeah, but we're pretty happy with how it came out overall. There's a lot of different information in there, and I think most importantly, there's a lot of diversity of information that doesn't show up in what other people are training on. That was a bit of a ramble, but I hope that made sense.
What's By the way, I'm echoing from you. Can you? Is there a possibility where can you put a headphone? It's okay if you don't. Currently, I'm not echoing. It's nice. So, were there any interesting findings in, for instance, bias or any other social impacts of the language models perspective that you can mention about GPT-Neo?
So we haven't done a lot of thorough work on GPT-Neo itself yet. We have done a lot more on the pile and kind of the quirks and intricacies of bias and also just unusualness in the pile itself, which we tried to document as best we could in the paper that we wrote. One of the big issues we had when it came to actually interpreting this, though, was that we didn't have anything to compare with. Like, okay, so in the pile paper, we have histograms that show like co-occurrence frequencies of gendered language and in certain terms. We did some sentiment analysis, but it's really hard to tell like what makes something good. Basically, all of the research on model bias and stuff or data set bias, and stuff like that, is focused on like, oh, this specific data set is bad for this very obvious reason. Like, there aren't very many standards that you can compare against and say, okay, like maybe this isn't great, but it's not the worst thing ever. And so kind of when we were doing a lot of the examination of the data set and documentation of the data set, we were less interested in forming like specific judgments about, oh, this is racist and not sexist or whatever, or not absurdly sexist or whatever. But we were mostly interested in just systematically documenting things so that when looking at other data sets, and hopefully when other researchers introduce new data sets, they'll look at similar things that we can actually compare between them. Other than, there aren't large data sets that have thorough documentation of frequency of profanity. So if you look at, one of the things we looked at was profanity. So about 0.4% of the pile as a whole is profanity. Is that a lot? Is that a little? I have absolutely no idea because I've literally never seen anyone document that for a data set before. But that does seem like very useful information to somebody who wants to train a model on this or consider that. Maybe they know that, or maybe they suspect that they know their model is going to be deployed with young children that they don't want to expose to profane language, or it's going to be used in a religious setting where people are going to be deeply embarrassed if it swears at someone. So a lot of the documentation we did, and I keep going back to the word documentation, was because we really felt like the best thing we could do is lay out what we found in the data, the ways it's good, the ways it's bad, and kind of give the tools to other researchers to compare their data sets against ours, and to developers to look at it and say, okay, I think this is acceptable for my context. Okay, I think this is unacceptable for my context. Because at the end of the day, we call them, general purpose language models, but that's not really true. Like, there is no such thing as a general context.
I saw a paper the other day called General Language Model, and there was a tweet about it, and it said computational linguists are going to be pissed off.
So here's the thing. People often talk about, especially when people are talking about data set bias, which is clearly, a point of concern, is that there is no such thing as a generalizable notion of what is acceptable content for a data set and what is unacceptable content for a data set. Even if you want to go the most extreme, if you are building a child pornography detector, you probably want to train it on child pornography. The vast majority of CV algorithms shouldn't be trained on child pornography, but some should. And I think that less extreme versions of that is just true in general. There are lots of contexts where it doesn't make sense to train on archive, to train on PubMed. Maybe you want to use your model to write children's books, and training on archive and PubMed is going to produce too complex of a language and too advanced concepts for that. There are so many different contexts and so many different use cases for these models that I want to be very clear that we're not saying it's not the responsibility of researchers to not build shitty things. But I do think it's the responsibility of researchers to give the people who are going to be using their tools the information they need to determine if they should be using it in the first place. And I think that's partially on us building things, and I think that's also partially on the people who are going to go deploy it, who should look at this and go, oh, okay, 3% of this data set is profanity. Maybe I shouldn't be doing this if I want to deploy it, using this if I want to deploy it in a school setting. The pile has like 1/10 that much profanity. That's probably a better option for me. And kind of looking at it in terms
I saw some
and trade-offs.
Model configurations you can use with GPT-Neo. Is it like, how does that work? Is it like, yeah, I'm going to use it without any profanity? Are the configurations like that, or how do they work?
Can you give me an example of a configure? Oh, you just mean like the config files?
Yeah, yeah.
Oh, so those are not about like, oh, train it without any profanity. Those are overwhelmingly model structure.
Okay, just like any other Hugging Face model, I guess.
Yeah.
Okay.
Yeah.
Also,
number
can you
etc.
Can you use GPT-Neo with like zero shot, few shot, or do you fine tune? How do you use it? Is it few shot mainly?
Yeah. So the checkpoints that we put on Hugging Face are just trained on the pile. They're not tuned on anything at all. So you can fine tune it. We know people who are having success fine tuning it. There's a couple people who run those like theme Twitter bots where they fine tune a language model and a particular corpus and then write tweets in the voice of that. So I know at least 2 people who are interested in using GPT-Neo as kind of the base for that. And it's been out for a week, but so far they've said it looks good. Zero-shot learning, especially on models this small, which is really strange to say because like 2.7 billion parameters is a lot. But in order to get like the really good zero-shot performance that you see in like the GPT-3 paper, it seems like you need to be a lot bigger than we currently are. So to give a sense of scale, the GPT-2 was 1.5 billion parameters, and the 2 models we released are 1.3 and 2.7. So a little bit smaller than GPT-2, and then about twice the size of GPT-2. The 2.7 is actually the same size as the smallest GPT-3 model that OpenAI sells API access to. So they have like the different tiers, DaVinci being the most powerful and Ada being the least. And so the GTP-Neo 2.7 is the same size as Ada and should be roughly comparable in performance. That's largely what our tests have indicated, but we've also had trouble replicating like the GTP-3 paper's results on their own models. So I think it's a little bit hard to do great comparisons because everyone evaluates their models a little differently. But it seems to be pretty comparable to Ada in most ways. That's at least based on the kind of standard language benchmarks. We are currently developing some benchmarks for that would do a better job of testing things like biological knowledge, mathematics knowledge. There's a math QA data set that we are currently implementing a test for. And so we're hoping that training on the pile is going to give it an advantage when looking at those things that are more factually based or require knowledge than your standard language model evaluation data sets.
Where did you get the computing resources, and how many GPU hours did it take to train the small and the big model? By the way, If the audience, if you have any questions, you can directly ask and Stella can answer.
So Google went and built these devices called TPUs, which are like souped up special GPUs for doing machine learning training specifically. And then they went, oh, we have a lot more computing power than we can actually ever hope to use. So they make them available for people to use for free, with the caveat being you can only use them when Google researchers aren't using them. So this is what powers a lot of the Google Colab instances. You can get GPU or TPU Colab instances. And then if you want some, the Colab, I think, gives you something roughly equivalent to a V100 when it comes to TPUs. And if you want more than that, you can apply to this program that I actually don't know the name of because they changed it last week. It used to be called TFARC, the TensorFlow Research Center, where you could basically write them a letter and say, hi, I am interested in borrowing compute for nonprofit reasons. Here's my cool project. Can I do it? And they'll say yes. And they're really free with their with access to their machines because, like I said, they are never going to be able to keep them full all the time. And so I think it's really good from a resource conservation point of view. Like, don't go building giant data centers when you can just borrow Google's in the downtime. And also, it's a great way to get free access to computing resources that wouldn't be available to most people. So our code base for TPUs is the GPT-Neo, and that probably isn't going to be able to get us to like 100 billion parameters, unfortunately. That's a mix of inefficiencies in our code and also due to the fact that you can only get like Google will only give you so much TPUs, and training a 100, 200 billion parameter model takes forever. So for that, we've switched over to a PyTorch basis that is designed to work on GPUs, and there's actually a cloud company that has very graciously offered to sponsor us. They're called CoreWeave. Basically, they are, they're a cloud computing company. They specialize in high performance computation and machine learning, and also I think sensor arrays and stuff like that. They're part of like the NVIDIA cloud program, and partner with NVIDIA on a lot of things. And we sort of have an arrangement similar to what is with Google, where they have all of these GPUs and they're not always being rented out all the time. So we're able to kind of just run code on the machines that they do not currently have sold to clients, which is really, really nice. Right now we're working at a scale of, we're working with about 48 A100s. And we're estimating that we probably need the amount of compute you need changes depending on how long you're willing to wait. Right. But we estimate that training GTP3 would take about 4,000 V100 months. The word month there always. The word what?
That's too much. I read from Emma Strugel's paper that if you were to train GPT-2 on a single computer, it would take 27 years, and for GPT-3, it's like 300 times of GPT-2. So it's pretty much impossible to build such model if you are not big tech, I guess. GPT-3.
I haven't read that paper. I don't really know where they're getting their numbers from, but I would say that that's probably misleading.
The paper is the energy policy considerations of the language models that was on the environmental impact of training a large language model and fine-tuning a large language model. Basically, GPT-2 is has a carbon emission of 5 cars lifetime carbon emissions. Yeah, that was We discussed about it. I was going super against training another GPT-3 for the sake of the environment. Do you remember that?
Yes.
That's how we met, by the way, if anyone doesn't know.
It's complicated. Like I generally speaking don't agree with that paper, but I don't really want to. But there are a lot of things it does well, and it's not the kind of thing I want to like talk about off the cuff for 5 minutes, if that makes sense.
Yeah, fine. It's just back then I was just advocating that, I mean, instead of training a gigantic model, what if we change the structure, the architecture of the model, for instance, not make it an autoregressive model, just make a better architecture. I don't know how, by the way, but make it better rather than getting the data bigger and bigger and getting computing sources bigger and bigger. You can simply change the architecture. Like, for instance, I find, BERT variants quite successful in that case. For instance, they are tapping the superglue charts and other language understanding charts without being gigantic. So I kind of advocated for this back then. So I'm sorry if I came very offensive.
No, it's fine. So first of all, I think BERT is very interesting, and the difference between kind of the autoregressive and the
bidirectional
models and the bidirectional models is very interesting. One thing that fascinates me is that nobody's really scaled BERT up very big. Like, okay, there's 3 people who have trained 10 billion parameter or larger models and have talked about it publicly, but there's 50 who've done so at 1 billion or larger. And the fact that none of them have used BERT is just, like, in my mind, very weird. One thing I would like to do actually is try to scale BERT and like look at what happens when you train it on 6 billion parameters. Like, does it do better than a 6 billion parameter GTP2 or GTP3? Like, BERT definitely has a strong edge when it comes to smaller parameter regimes. I would take a 600 million parameter BERT or ELMO or whatever over an autoregressive model like GTP3 that's been downscaled to that size in a heartbeat. I don't think that's close. And I think it's a really interesting question how different architectures and different training methodologies kind of influence performance. And it's not necessarily that one is better. It's totally plausible that BERT has the edge when you're small, and then once you get to about 3 billion parameters, I'm making these numbers up, I don't know, but once you get to a certain size, GTP2's architecture, GTP3's architecture starts performing better. And I think these are really good questions and really important questions. They don't seem to be questions that have, they're expensive questions is really what it boils down to.
I recently saw a paper called Pattern Exploitation Training, PETS, and it's rather a small generative model, but it is said to perform better than GPT-3. Again, it's an expensive question to question their performances and accuracies, etc. So let's not go into it. But what I can say is, Google not recently actually, after GPT-2, I guess, released T5 model, which is relatively bigger. There is a billion parameter. That's a billion parameter size model, by the way. It's way bigger than BERT, and you can do generative tasks as well. So I think you can find something that answers, I have scaled BERT to some extent and what happened. But by the way, BERT is encoder only, and T5 is encoder-decoder model. So it might not answer your question, but by means of generative model that is somehow like a BERT, it might answer your question. That's like a Swiss Army knife, by the way. I don't know if you have ever used T5, but it can do any task, basically. I'm always amazed by it. By the way, I want to talk about lastly, I want to talk about your Magic the Gathering paper, because I was a Magic fan. I I played it during the university. I even missed linear algebra classes because I couldn't leave the table, basically. I had this deck, and it was a vampire deck, and there were two cards. They are probably like banned or something. One was basically, the times that it hits you, you also gain life, and as you gain life, it hits your opponents. Basically, if you can have those two enchantments, then you can infinitely hit your opponent and they basically die.
Sanguine
And
is where
I,
it came from.
yeah. And I had another forest deck that was consisting of gigantic creatures. That was also awesome, but you need to survive to a certain level to get your, because it requires a lot of mana and forest mana, obviously. You shouldn't be dying early to get through it. And then I quit it because I was in the role playing club playing it. Then I quit the club and I just played Hearthstone after that one. So how did you came up with the idea of, oh, let's calculate this Turing completeness, let's find out about how this what how can I put this into words? Let's calculate the complexity of the game. Like,
so this
did it
this
just
is
hit
something
you?
yeah, this is something that's kind of been in the air for a while. And by a while I mean like 10 years. A lot of people felt like it was probably true. And there were people who in the past had tried to make such devices, or such, I should not devices, yeah, sure, such devices. And some that came really close. The origin of this project actually was, I was looking at a write up on the internet by someone who had built parts of a Turing machine in Magic. And he said, if you're interested in this, shoot me an email. So I did. He was like, I haven't looked at this in 2 years. His name's Alex. He's pretty cool. But I was actually thinking about this the other day. So that's really fortuitous timing. Like, let's talk about it. And we started talking about it, and another friend of mine joined, and we kind of just kept slugging at it and filling out the niches and making everything work. The final construction we ended up with looks basically nothing like what it did when I first emailed him, but that was, it went through a lot of iterations of how do we make things better, how do we get around the large amount of very niche rules interactions to make sure everything comes out exactly how we want. But yeah, so I mean, people have been talking about stuff like that forever. I remember back in 2010, there was this web forum game that that Magic players played, where you tried to come up with a combination of cards that would gain, produce the biggest number, gain the most life, gain the most mana, like whatever it is, but not actually be able to produce infinitely much. So if you can go infinite, you can do anything you want. You can make really, really huge numbers. But the idea would be, can you come up with a combination of cards that can make 100 trillion tokens and no more than that? Like, there's actually a ceiling. It's just really, 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 really high. And kind of one of the cards that really motivated this was called Rite of Replication, which came out in like 2011 or something like that. Because it made 8 copies of a card. And there's this funny combo with a card called Precursor Golem that when you play it, you get 2 Golem tokens, and it says whenever a spell you cast targets a Golem, copy it and cast those targets, or cast those copies targeting every other Golem you control. And so basically,
You will have gigantic golems.
Right, so basically anytime you cast a spell that targets one of your golems, you get that spell for all of your golems. And then when you combine that with the fact that you're casting a spell that says make 8 copies of this card, or maybe it's 9, I don't remember off the top of my head, that gets a bit silly. And so that's actually like what I got into, like building wonky things in Magic with. I was just really curious, like, okay, if I cast Ray of Replication targeting Precursor Golem, great, I can do that math. What if I do it a second time? It goes crazy because now you have like 8 cards that are all you have 8 of the main golems that copy it, and so you end up with way more copies and this faster than exponential growth. And that was just like something that I like talking about on web forums and stuff for a long time. And I like puzzles and I like building things and making intricate gadgets. I have made crosswords before, and this is kind of just a natural continuation of that interest.
How did you build it? Like, did you build the Turing machine itself? I don't know how it works, by the way. Like, I am slightly into computational complexities, efficiencies, etc. I try to improve myself, but I really want to like do cool stuff like this at some point. I'm just very novice, I guess. So how does it actually work? Explain to me like I'm 5.
So I'm not going to be any good at doing that.
Okay.
But in large part because of the medium, like maybe with diagrams and a lot of chalkboard. But I do have a video that I can share with you and with everyone who is listening in.
Okay, post it in the chats.
Yeah, so this YouTuber with Because Science, his name's Kyle, wanted to do a piece on it. He just does these videos on wacky science things. Some of it's math, some of it's physics, some of it's chemistry. A lot of it's related to things in pop culture. And he found out about this and went like, oh, that's really cool. I want to learn about how this works. And we talked with him for a long time, and he was like, okay, this is super cool. I want to make a video doing it. So he actually, in the video I shared in the chat, I think that shows up to everyone, maybe? Yeah, so in that video, he walks you through like how it actually works, as well as kind of the design pieces. And in my mind, that's the best short explanation of how it works. I say short with air quotes because I think it might be 22 minutes long, but relatively short at least. Big picture, what it does is, so a Turing machine is a idealized device for doing computation. And what that means is that it has scratch paper, and it can write symbols on that scratch paper, and it can read symbols from the scratch paper and use that to make decisions about what other symbols to write down. And so one of the big limitations with building something like this, and why I believe it's a similar construction wouldn't work in similar games like Pokemon or Yu-Gi-Oh, is that you actually need to have an infinite amount of scratch paper. If you don't, it just doesn't work. So having an infinite amount of space to write symbols in is tricky. And the way we manage that is with creature tokens, because there is no maximum number of creatures you can have in play. So we have creature tokens, each one representing a different cell. So the tape starts off, the scratch paper starts off totally blank, so like no creature tokens. And then as you write down symbols, that corresponds to creating creature tokens in the game. And getting it to kind of move around in scratch paper, you don't want to always write on the same, you can think of it as like a piece of graph paper, you don't want to write in the same cell all the time. So we keep track of where information is relative to other pieces of information with power and toughness. It all sits in a line, and you're from the point of view of like the reading head. So you have a tape going like back and forth. And so that like the power of a creature tells you how far away from the reading head it is. And that kind of basic concept was something that Alex had developed on his own years ago. The real question was, how do you actually get it to interact correctly with all of the other stuff that needs to happen? You need to make it automatically automatically follow a program. You need to make it so that players don't actually have any options anyway to interfere with its operation. And so we started with the basic instruction of like, here is a tape, here is how you encode information on it. And it was kind of like an iterative process. Like we took something that he had made that we knew like had certain problems, and we tried to fix those, and fixing those broke other things, and we kind of went back and forth until it all worked.
That's actually awesome. I'm gonna watch the video because I really want to learn about this stuff. Thank you so much for coming to my podcast. I don't want to take any more time off. It's already 15 minutes. I didn't realize how it passed.
Time flies.
It was awesome talking to you. So seeing with that we don't have any questions, we can end the broadcasts. Hopefully I will see you again.
I look forward to it.
Bye.